Today I want to talk about another fascinating topic in quantum mechanics, one that sits at the very heart of quantum computing. It's called superposition, and the simplest way to understand it is with a spinning coin. Imagine flipping a coin. When it lands, it's either heads or tails. That's how classical computers work. A classical bit is always a 0 or 1. But while the coin is spinning in the air, it's not heads or tails yet. It's in an in-between state. That simple idea is the best everyday analogy for quantum superposition. A qubit, the basic unit of a quantum computer, isn't just a 0 or 1. Before it's measured, it exists as a combination of both at the same time, like a spinning coin. Now, here's where quantum computing actually starts to matter. The power of a quantum computer does not come from the coin eventually landing, it comes from what happens while the coin is still spinning. In a quantum computer, algorithms carefully control how qubits evolve in superposition. They apply operations that change the shape of that spin, adjusting probabilities, phases, and relationships between qubits. This is where quantum computing becomes fundamentally different from classical computing. A classical computer checks possibilities one at a time. A quantum computer uses superposition to represent many possibilities at once, but in a very controlled way. And this part is important. A quantum computer does not give you all the answers. When you measure the qubits, the coin lands. Superposition collapses, and you get a single result. So how is this useful? Quantum algorithms are designed so that wrong answers cancel out and right answers reinforce each other, while the coin is still spinning. By the time you measure the system, the correct answer is far more likely to appear. This idea, using superposition together with interference, is what gives quantum algorithms their advantage. That spinning coin state is incredibly fragile. Any interaction with the environment, heat, vibration, electromagnetic noise, can disturb the spin and cause the qubit to lose its superposition. That process is called decoherence. And once decoherence happens, the quantum computation fails. This is why quantum computers need extreme conditions, ultra cold temperatures, carefully isolated environments, and sophisticated error correction. So when people say quantum computers are doing everything at once, that's not quite right. They're carefully shaping the spin of many coins at the same time, and then letting them land in a way that reveals useful information. Superposition isn't magic. It's a physical phenomenon that quantum computers use to explore problems in ways classical computers simply can't. And understanding that spinning coin is the first step to understanding how quantum computing really works. If this helped make superposition feel intuitive, go ahead and like the video. And if you want more clear, no hype explanations of quantum computing and the physics behind it, subscribe and stick around.